So let's go ahead and do the section 9.2 additional exercise. So we want to evaluate the function at the given value of x. Round to 4 decimal places if necessary. So our function's 5x, and here we're finding f of 3.3, so I'm taking 5 to the 3.3. Let's clear this out. And so let's go ahead and type it in. 5, caret key 3.3. So if we round that off to 4 decimal places, that'd be 202.5821. All right, let's do the next one. Now we're raising to the square root of 3, so I'm going to do 5, caret key, second squared key, 3. Get out of that, hit enter. So that would be 16.2425. And let's try C. So that's 5 to the E. All right, that's kind of weird, but let's see how that works. 5 caret key, second ln. Now, if your calculator is prompting you to put an exponent for E, remember there's no exponent. Remember, we assume it to be 1, so we'll just type a 1. Hit enter. So that'd be 79.4324. All right, let's try this next one. All right, so now we're taking 1/3 and we're raising it to the negative 2. And some of you might realize that's just going to be 3 squared, which is 9. But if not, throw it in your calculator. And it gives you the answer. No rounding here on that one. Let's do B. So I'm going to do parentheses, 1/3, close my parentheses, caret key, make sure you're up there in the exponent. Second, get your square root, put your 2, hit enter. Now it'd be 0.2114 if we're rounding to 4 decimal places. And let's try C. So that's 1/3 raised to the pi over 4. So that's going to be an interesting one to do. So I'm going to do parentheses, 1/3, caret key, parentheses, fraction key, pi over 4. Close that parentheses off. Hit my right arrow key and hit enter. And I guess we need to round that to 20 there at the end, so it'd be 0.4220. Okay, let's try this one. So that's e to the negative 4.5. So I'm going to do my second ln, negative 4.5, hit enter. Ooh, that's pretty small. 0.0111. Alright, this next one's going to be kind of weird, so let's just kind of do this one slowly together. Let's do my second ln. And do my square key to get the square root. I'm going to do my second ln. And again, if it's prompting you, if you have plain E, you put a power of 1. Hit enter. So 5.2003. Alright, let's try this bottom one. So this is e to the pi. Second ln, do our pi key, hit enter. 23.1407. Okay, so here we'll graph the functions, write the domain and range. So we have 2 to the x. My base is bigger than 1, so my base, it should be going this way. So I can eliminate a, and I can eliminate d. So it has to either be b or c. And remember, for exponential functions, domains are all real numbers. That has the wrong domain. This has the correct domain, this has the correct range, so our answer has to be C. And, oh, looks like this is a repeat. I'm not sure how that happened. Okay. So I tell you what, let's change this. Let's make this problem number 5, and let's make this 1/3 to the x. Alright, so looks like that was a typo. So we'll change this to, on this page, we'll change this to problem number 5 and make that 1/3 to the x. And hopefully with that correction will be made into the workbook at some point. Alright, so I want to graph the function, and then I want to write the domain and range. So remember, this is, base is smaller than 1, so my graph should look like this. So I'm going to eliminate A, and I'm going to eliminate D. So it has to either be B or C. Looks like on B the domain is correct and the range is correct, whereas C the domain and range are not correct. So my answer choice has to be B. Alright, so this is now, we're on complete the table and determine the effect of the number of compounding periods when computing interest. Suppose 13,000 is invested at 3.8% interest for 17 years on the following compounding options. Round your answers in the second column to the nearest whole number. Round your answer in the last column to the nearest cent. So annually ends 1, quarterly be 4, monthly is 12, daily I already told us 365. Alright, so that's pretty easy. And compound continuously, we have to use the other one. So we're using our compound interest formula. A equals P 1 plus R over N raised to the NT. Principal is 13,000. So I'll call this part A here. I'm going to have 1 plus our R here Going back up here, we're going to need to write that as 0.038. Slide the decimal point over 2 places. And here is 1. And then I put 1 up here. And let's see, what they say for time? Looks like time is 17 years. Now for B, C, and D, we're going to be doing the exact same thing. The only thing is we're changing the value of n. So for B, n is going to be 4. For C, n is going to be 12. So it's the same thing. And for D, n is going to be 365. And so we're just going to kind of do the same thing for each one of these. So let me grab the calculator. So here we got 13,000. Oops, got a little carried away with the 3's there. 1 plus, to our fraction key, 0.038 over 1. Right arrow, close it. Do our caret key, 1 parentheses 17. And I'm going to hit enter. So it would be $24,507.46. Now I'm doing the exact same thing in part B, but I'm changing n to 4. So I'm going to go hit my up arrow twice, highlight it, enter. And I'm going to change those 1's to 4's. Hit enter. So that gives me $24,727.11 if we round that off. Doing the same thing in part C. I have to change those 4's to 12. So I need to change that to a 12. And I'll probably need to just retype that whole exponent. Hit enter. To $4,777.32. Now I'm doing the same calculation again for here, but now n is 365. So I'm going to change that 12 to 365, and then I'm just going to retype the exponent. 365 times 17. Hit enter. And slide back over here. This will be $24,801.79. So it's the same calculation over and over. I encourage you to use your calculator when you're doing that. So I can put these results in up here. All right, for this last one though, it's compounded continuously. So that's where we use the other formula. A equals P e to the RT. P is still 13,000. E, my R is this 0.038, and then T is 17. See if I can write that a little bit better. So let's do that calculation. $13,000. Second ln 0.038 parentheses 17. And that's going to give us $24,802.62. And then we're also going to put that up here. And so notice here that as your compoundings increase, the amount of money you end up with increases. And that's what should happen when you're doing these problems.